Section is entitled Scheduling. Understand how resource limits can affect pod scheduling. So far when we've created pods, we've not really worried too much about how much RAM they were using or how much memory they were using or how much CPU they were consuming, right? We just kind of let them go. And in this section, we're going to explore how, when we create these pods, we can put more constraints around how much resources they request and how much resources they can ultimately use. So the basic pattern here is we're going to focus on just two things: CPU, right? How much processing, and RAM, just how much memory they're going to use. So CPU and memory, actually. And then there's sort of two factors or two constraints that we're going to supply, right? One is going to be called the request parameter, right? And that's basically before the pod can be scheduled, we're going to make sure that the node has at least that much. That's what the request has to do with. And just so you know, the node is going to also ensure that you, at least over time, that much resources is set aside for that pod, right? And I step back. Actually, I mean this. What actually happens is all the constraints we're going to put are on the container level, but then they sum up into a sum, because you sum across all the containers into a pod, overall pod value. So again, these constraints happen at the container level, but they roll up to a pod. And then, so that's what the request is how much does it need to take, how many resources it need to start. And then limit is a second constraint, right? And you don't have to supply both. You can supply one or the other or both. But limit says, okay, this is how much I'm going to maximally use. And what will happen is if you exceed that number, the node is going to take, kubelet's going to take, or node, this matter, and or kubelet, right, is going to take some action based if you exceed that limit. So limit is sort of a guarantee that you're making as a developer that this pod will not exceed this. And if you do, somebody else, in this case the node, is going to take some action to immediately fix that problem. So request is about scheduling, essentially, and limit is about during execution, what happens. So let's talk about what the two constraints are. So again, CPU is measured in CPU units. Basically, a CPU is one processor, right? Think of your computer. And then the units are one, this is a number. And if you give a number, it just stands for the number of CPUs. You can actually, I don't have it written here. Oh, here it is right here. You can do fractions like 0.5, right? But it's more common to use this format here with a thousandths, a milli. So like a 100 milli M stands for 1/10 of a CPU. So a lot of times you'll see this, I think it's described as a milli CPU. Okay, so again, oftentimes your process is not necessarily consuming a whole CPU. Okay, the memory, on the other hand, is just measured in bytes, right? Now you can actually, there's two different, there's the kilobyte, megabyte, gigabyte, terabyte, petabyte, and I have no idea what E is. It must be can't imagine that much memory. And then there's also the I versions of them, and so this is the base 2. So like, this is like 1,000 bytes, and then KI is, I think it's 1024 bytes, right? So you can use either one. I think a lot of the examples are going to use the I version since that's more common for memory. Okay, so again, those are the two main constraints we're going to do. And let's see what's here. Okay, so we're going to talk about the request and scheduling. And I think I already said it. Essentially, the way the scheduling works is when you supply the requests for a pod, the scheduler is going to look at the sum of all of the containers and all the requested CPU, for example, and ensure that the node that's going to get placed on has at least that much. And then once it gets placed there, that node will basically deduct that from its pool. So it knows that it's not going to, it's basically taken away from the node's overall capacity. So what we're going to do is Now, actually, I wanted to look at something here. Yeah, I want to describe the nodes real quick so we can see Helm, describe nodes. No, kube, control, describe. So before we do anything, I want to look to see, let's see what we got here. So you can already see, let me look at a node here. You can see there's a whole section here having to do with request limits, right, and memory limits, CPU limits, and memory request limits. So wait, there's CPU requests, CPU limits, memory requests, and memory limits. There's 4 things, right? And you can see that we have a bunch of processes or pods already running with our containers, and that's what you're seeing here. These are basically all the pods, right? And then these are the sums of all the requests. Like first, let's just focus on CPU. So you can see that CloudWatch agent here has asked for 200 milli CPUs, or that's basically 2/10 of a CPU, right? And it's also said that it's essentially, it's saying that I'm not going to exceed more than 200 milli CPUs either. So it's saying I want that much, and if I exceed this much, let the node take some preventative action. And we'll talk about what those preventative actions look like later. So, and if you were to sum up all the, let's just focus on requests now. If you sum up all the requests right here, you will notice that all adds up to this number right here, 520. So basically, this node has set aside 520 milli CPUs, which is, this is a 2 CPU system, right? T3 medium is 2 CPUs, so it's basically a quarter, right, of the CPU is already kind of allocated. So doesn't mean it's actually using it, right? It just means that it has held that much aside to allow those processes to grow to that much. Okay, and then the other thing is so there's essentially 2 that we're going to focus on: memory and CPU. So the same goes for memory. So that this is, I think it's a 4 gig memory, right? And if you add up all the requested memory limits, you will see that it's asking for about 470 megs, right, of memory to be set aside for these pods, right? And then the limits, again, those are basically the levels in which these pods are saying, hey, or the containers, which then roll up the pods, these are saying if you exceed this limit, take some preventative action. Now, interesting enough, some of these containers, right, they actually provide, like, here's a good example here. This one right here says it's giving a limit on it's giving a request for CPU, but it's giving no limit. Which essentially, no limit essentially means, hey, just let me do, I'm going to ask for this much, but don't, if I go over this, don't worry about it. So it's interesting that they did that. They asked for something, but then they ended up not giving a limit. So either way, so that's kind of the summary of how these limits, like how they all kind of come together, right? The containers roll up the pods, then all the pods roll up into a total for the node. And then the scheduler then decides, based on the available requests, whether or not it can schedule a pod, right? Okay, so I think we'll go to an example. This will become more clear. Right, so I want to look at this example here. I'm going to call CPU request here, a successful CPU request. So let's look at that. Excuse me. CPU request success, right? Charts, no, templates. Okay, so I'm making a pod. It's just Ubuntu. What's new is this section here under resources, right? So this container is requesting a quarter, 250 M of a CPU, right? And there's only one container, so the whole pod essentially is only asking for this, right? And if I looked at if I look back at that, what was in the above, right? This node right here certainly could handle 200, because this thing goes up to, this has 2 gigs, 2 CPUs, which is essentially 2,000. So that extra extra 250 I'm asking for certainly could fit on that node, right? So this should be able to be scheduled. So if I do ls cd 28, no, 30, I'm on the 30. Helm install dev CPU request success. Okay. Okay, so deployed, kube control, get all. Okay, I see it's running, right? And if I do kube control, get nodes, let's see if I can see where it got. Oh, now what did I do wrong? Oh, describe nodes. Okay, so I'm betting it showed up. See, default. It must have landed in my first node, which is up here. Here it is right here. So you can see right here, this entry, right? It popped in there. It requested 250 millicPUs, and that then deducted that 250 now is part of the sort of the consumed CPU, right? Even though it's not, this process is not consumed. It's essentially, if I well, let's do something here. So I've asked for 250 millicPUs, right? And the node is essentially allocated it, saying that, okay, that's much as there for it. If I actually were to do top pods, let's see if the metrics are there yet, right? You can see that it's actually only using 1 millicPU right now, which essentially is nothing, right? So even though I requested up to 250, and I'm only using 1, but the point is that the request still at this, I mean, basically the CPU from a node perspective has already been pre-allocated. So even though I'm not using it, the node is holding on to that memory so that that pod can be serviced should it reach its request limit. Okay, even though it's not currently using it. Okay, I hope that made sense. I guess the point of the summary is that just because you request it doesn't mean that you have to that you're using it. And I guess just because you're not using it, the system still is holding on to that requested amount, even though you're not currently using it. Okay, now let's do a failure example. So let me go here. Let me get rid of this one. Helm uninstall dev. Okay. CPU request failure. That's what I want to look at. Templates. So you can hear I'm asking for a full 2 CPUs, right? Now, if you think about it, these nodes each only have 2 CPUs total, and they're already using some of that space. So there's no way this process can run, right? Because I don't have 2 CPUs floating around. So to validate that, I can do helm install dev request. I already forgot what this is. Right. So helm install dev CPU limit. Not limit. So I'm doing the request one right now. Failure. Whew. Okay. We'll get the limits in a minute. So this is only about the requesting process, right? And you notice I haven't supplied any limits at all. So these processes, should they get deployed, they'll be allowed as much memory as they want to use, or as much of anything they want, as much CPUs they want. But this one, it asks for 2 CPUs just to start, and well, that's not what I wanted to do. Okay, first thing you'll notice is that it's not going to be running, right? So let's describe what's happening to the pod. Kube control describe. For some reason, it's still pending, right? And in fact, you can see in the warning here, failed scheduling, default scheduler 02 nodes are available, insufficient CPU. That's because we asked for 2 CPUs. And you can see the status of the pod. The pod's going to basically sit here and the container itself, right? This is going to keep on cycling here. Just it's going to keep on retrying it, right? Now so right now all you're going to get is just going to keep on. Where's that status at? Container conditions scheduled. Status pending. Oh, I mean it's here. I'm just trying to figure out. When describing the pod, yeah. Hang on, let me get the pod. I think you get more detail when you get the pod. Example dev. The status. Yeah, unschedulable. I guess you just get, it's in this condition you get more information here, right? Zero negative CPU. Right, okay. So long story short, this will never actually run in this environment. So let me get rid of it. Okay, went away. Okay, so that's pretty much all there is to about resource requests and then the scheduling process, right? Now limits, we'll look at limits now, right? So assuming that the pod gets scheduled, while it's running, you can put limits on what happens if it decides after the fact to, or in actual reality, right? It starts to exceed limits, right? And there's memory limits and there's CPU limits, and they behave differently. So just to add to confusion, right? There's different behaviors if you exceed one versus the other. So let's talk first about memory limits. If you exceed your memory limit, essentially it will basically kill that container, right? And we'll restart it. So the pod will stay up, but it'll just keep on continually killing off that container. So that's essentially what happens when you exceed memory. Now CPU is a little more preventative, where in this case, if you try to exceed the amount of CPU, it just hard limits you. So the process doesn't die, the process essentially slows down that process to a point where it doesn't exceed the CPU limit. So it's like a throttle. So it doesn't really impact the container other than a performance issue. Okay, so we'll look at both of these first. So we'll look at the CPU, what a CPU failure looks like. And it's really not a failure, it's more of a limit. But let's look at this by example. So I think I have a comment code here for CPU limit. It's a failure in the sense that you don't achieve the full speed that you're asking for, or you hit your limit, essentially, is what this amounts to. The word failure is a little incorrect here. Okay, so this pod, I'm requesting 250 milli-CPUs, right? But then I'm going to put a limit saying, and again, I didn't have to put a request in here, but it felt weird to put a limit on without a request, so I did both. But you don't have to have both. So what I'm paying attention to right now is that I'm putting a limit of 500 milli-CPUs, which is a half a CPU, but I'm using this stress library that's going to basically press try to use up a full CPU's worth of number crunching, right? And so what we're going to see is, well, we'll just see it when we run it. It's not going to crash the container. It's going to basically limit the container. So if I do this, if I do helm install dev CPU limit failure, so I do kube control get all, you'll see the pod's running fine. Let's look at the describe pod example dev. You can see that I certainly have put a limit of 500, right? But I don't see anything here telling me there's a problem, right? Everything looks fine. So as far as I'm concerned, everything's working fine. Now, here's what you'll see, though, if I do a top pod, and let's see if I have metrics. Oh, I don't have metrics yet. It takes about a minute to get metrics. Let me give it another 10 seconds. If it's not here, I'll pause the video. I'm going to pause the video. Hang on. Let me run the top pod now. So you can see now my example dev, I had really was pressing it with that stress library or step container to use up one CPU, but you can see that I was limited down to basically 500 millicPUs. That's because the limit proactively prevents this from exceeding that amount of CPU usage. So that one's kind of handy. It's kind of hidden though. I mean, it doesn't give me any warnings. It just prevents it from operating over that amount. Now, let's look at the next example. Let's see what happens when you limit memory, on the other hand. So the example here is, I have to get rid of this one. Hang on. Helm, uninstall, dev. Okay, let's go back into the code. Let's look at memory limit failure, because we'll find it behaves differently here, and we'll talk about it for a second. Okay, so here I'm going to now only give a memory limit. Right? I'm giving a request of 500 megs. Again, it wasn't required, but this felt weird not to have it. But I'm saying, okay, give me 500 megs, but then let me basically grow to 100 megs of RAM, right? But you can see here, I'm actually running the stress library that's going to immediately try to use up 200 megs of RAM. Now, what's going to happen here is, and if you think about this a little bit, there's no way that the system can constrain you to the 100 megs because the process actually needs the 200 megs to operate, and it wouldn't know. I mean, that process can't cut half of its brain out essentially. I mean, it can slow down the CPU. That's fine, but it's another thing to try to chop off half of your memory and somehow still operate. So in this case, this container essentially gets killed, and then it tries to restart it. And if it exceeds it again, it just kills it and restarts it. Okay. So in this case, I'm expecting the node essentially never to let this run, because immediately, in the moment this thing, it runs for about a millisecond, and then this stress thing starts pounding the memory. So let's just deploy this one. Helm, install dev, CPU, memory limit failure. Okay, and then let's look to see what happens in the logs now. Kube control get pod. Oh no, let's describe the pod. Well, let's get the pod first. Okay, so the pod is not running. It's in a crash loop backoff state. And if I describe the pod, you can basically say right here that there was a basically backoff restart failed container. And then if there's any detail here, should be more detail, but why it crashed. Oh, here it is right here. Out of memory killed, right? So the reason why it was killed is because it was out of memory. And that's because we put a hard limit of 100 meg, right? And we know the process, just because we forced it, it's trying to use up the 200 megs of RAM. So this will never, I mean, it was scheduled, right? Because there was enough memory to run with the 500 megs of it, right? 50 megs on it. So it scheduled it, started to run it, it ran out of memory, immediately killed it, and it's going to keep on doing this. It's going to restart it, kill it, restart and kill it. Okay, so that's it for that. So helm uninstall dev. What's left? Okay, I was going to touch upon it in this video, but we're not going to actually do anything with it. There are some other resources. We talked only about CPU and memory, and those are the biggies. There's other resources that you can put limits around, and one of which is ephemeral local storage. So if you think about it, right, we were always talking about how the writable container layer, right, just eats up disk space on the node, and it's up to you, the developer, to be careful. You're supposed to only keep a small amount of data in there. And you might be worried that, well, what happens if this process goes crazy and just starts spewing a bunch of log files or something unwittingly, and you want to keep it from blowing up your node? You can actually put limits on the amount of storage that they actually can use. I think this feature is a beta feature, so I didn't, and it was a little bit complicated. I didn't want to go through the whole example, right? And then the other one is you could actually, so that's one big one you can do. Another thing you can do is you might have other resources that have nothing to do with Kubernetes. I don't know, number of objects in a table or something, or something that's very specific to your application. So, and it was a little bit confusing, but there was a concept that you can define other kind of constraints, right? And then you can then have kubelet like enforce those constraints. And it's not, there's some documentation on it, but definitely would require a lot more work to explore that. Again, that didn't seem like it was like something that I would probably spend a lot of time studying for my certification exam. But so the main things here are CPU and memory, and just know that you can also reserve ephemeral storage relatively easily. And if you're so inclined, you can also have any sort of constraint enforced. But you have to do a bunch of custom, I'm sure there's custom coding around that one. Okay, I think that's it for this video.